So we are actually right, right here. We're going to do this projection thingy. Now, we did the scalar. We went to go find the formula. You wrote it down, so now you have it. But the projection one for sure we have. So I'm going to go back up, and it looks funky, but this is it. I'm going to give you my version, and this is the one that I actually remember because to me it's easier to remember. So here we go. It's equal to u dot v divided by v dot v and then times v. So that's my formula. That's supposed to be an equal sign right there. So that's my formula for it. It looks similar. The only difference is in the bottom. Instead of magnitude of v squared or whatever they're doing right there, I put dots. But that what it does is it, for me at least, and they are equivalent. Okay, and then you multiply it by v. So far, is that okay with the formula? Oh, y'all are writing it down. That's cool. I need to get like thinner thickness stuff. There we go. Times v. Just like these guys, it's like multiplied. Let me try again. So u dot v, and then I got v dot v, and then this whole thing times v. Yeah, because this ends up being a number of some kind, and then we're just saying like 2, and then you say 2 times v basically. Cool. So there's the formula. I'm gonna go down and we're gonna do it again down here. But like first off, what is a projection? Now that I got a lot of room, I can actually show you. So we have 2 vectors. Okay, I'm gonna do the u and I'm gonna do the v vectors, and I want to know what would the shadow be of the u on v. Okay, so in a way here, I'm kind of like doing this, and this has got to be 90 degrees by the way. I'm doing this shadow of the u on v, okay? And what we're doing is I'm saying that it's the same vector as v, right? That's our formula, blah, 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 times v. I'm just changing its magnitude. So it might be half of v. It might be 2 times v. But it's taking this u and it's like shadowing it onto the v vector, okay? So this right here, this would be your projection vector, I guess you could say. And so it's conceptually really fun, but the math is really just really simple. So here I'm going to rewrite it: u dot v, v dot v times v. So I have to go back up. I'm going to go back up because I don't know what my u's and v's are. Oh yeah. I wonder if there's an easy way to do this one because they're all the same numbers. You know what I mean? I'm sure there's a way, but I just do it. I just do the math. Yeah, here we go again, I guess. It's a dot in there. It's like really clunky looking, and all that's supposed to be times v. So here we go. Just, I mean, it's so clunky, but that's just how we roll, I guess. So here we probably already did this. Did we do u times u dot v? Yeah, wasn't it? But like negative 42. Thank you. That was from yesterday, right? Like I don't have to go through and do all that again. Negative 42. And then these guys, if I did v dot v, I think we get just a 42. I'm gonna check it out. So we got 36, 4, and then square root of 2 times square root of 2 is just a 2. Yep. And so I think that's 42, isn't it? Awesome. So we got a negative 1. All of this here, I was just doing this part. I'm so sorry. I keep forgetting to put v in there. v. So it's negative 1 times v. So negative 1 times v would be negative 1 times, well, the v vector. So here we go. 6, 2, square root of 2. And oh my goodness, it looks the same. I'm going to double check myself here in a second. Oy. Here we go. I'm just going to flash it right quick. 6, 2, square root 2. But why do I have negatives? They have positives. Was it negative 42? Yeah. Why do they have positives, not negatives? I'm gonna have to go look into that. I don't know actually. We're gonna figure it out. Let me go back up for a second. Verify u.v, v.v. I mean, even with this, it will be a positive. This is the negative. This is the positive. And so we should be getting a negative times that amount, right? Ah! No, wait. Hold on. Did they flip it on me? Oh, no. They did fine. Look, V and U. Is it V and U? Okay, it's fine. What's up? We're going to check again. It's all positives. But I don't know. Is my V negatives? Yeah. My V is negatives. Oh my gosh. Okay, we need. There it is. Very first problem. Already messing up. Negatives here. 2 negatives make a positive. Wow. Thanks, Chad. Okay. I would love it if they didn't have the same numbers up there twice, but that's our homework. So, okay. Thank you. Good. I mean, the math was fine, right? Okay. I just can't get anything right over here. Okay, so let's do something fun. Gun with a muzzle velocity of this much is fired at 14 degrees above the horizontal. Find the horizontal and vertical components of the velocity. We already did something like this. Didn't we? There it is. R cosine theta and what would be my R? Are you sure we didn't do this one already? Oh, I remember now. Well, it's nice that we have the same question 5 times. I guess. Okay. I would want y'all to go to the board for this, but because it's the same thing, it's just sad now. And it's in degree mode, and then we're done. So there was really nothing to do with that problem. That was an easy one. I want y'all to go to the board for the next one, but we're going to see how that is. Oh, you want to see the answer? Let's flash it. Here we go. And yep, we're good. Cool? Good with that? All right, cool. I'm going to move on. Sometimes they're just easy. Okay, so suppose we have a box inclined on a plane, and we want to find the force W, which I'm guessing is how much they're pulling up on that right there. Do we have a formula for force? Yes. Or force times distance. But that's work. Are they looking for work done, or just that actual force? Just the force? Okay. Oh yeah. It's yeah, that's not work. There's no way that W would mean work. It's a force. That's okay. Yeah, this is a great opportunity for y'all to try something out. Okay, so I'm gonna have y'all do it, and here we go. In the spirit of doing it on the board, you wanted it. I'm erasing it for you, bro. All right. If you want to do it on your paper, that's cool. If you want to do it on the board, that's cool. And you can talk about it or you not talk about it. Your call. There you go. You're not getting up to the board like you said you would. We're going to have it anyways. I will say now, you can do all the homework you want before class. No problems. Even after class. And again, I'm not seeing if you can get it right or wrong. You know I get things wrong. I'm just, I want to see what you're thinking. What's the thought process for this? be that first step? Oh, this is an interesting one. I like this problem all of a sudden. This is going to be terrible. I meant great. It's going to be terribly great. When they say awful, it's not bad. It's just like full of awe. Oh, guts? Really? Oh, interesting. Oh, I see. Yes, yes, I remember that now. You want me to try something? Or are y'all still doing it? Really? But that's good. It's good to admit that. Thank you. Y'all don't have to admit it. He did. And it is tough, isn't it? This is a weird one where they're saying that the parallel force to the plane. So what I'm doing is we have a 16 and a 33. I'm going to redraw this. So I have my 16, right? And then I have a 33, which is with the horizontal, right? But they're wanting it parallel to this plane right here. So in a way, it's like I'm wanting to do that with it. I want to go this way with it, kind of, okay? So this would still be 16 right here. What would be the difference in here then? Uh-huh. Calculator. 17 degrees. What I'm going to do is I'm going to reimagine your entire world with this being our coordinate plane. So in a way, I'm going to redraw what you see right here on the top. And now I'm only going over here at 17 degrees. Okay. The box is right here. This is where that box is right there. And this is the plane that it's going to be sliding on, this one right here. And in a way, like way back here is that 16. It's like I literally had to rotate everything in order for that to be flat now. Okay. And what I'm thinking, just between you and me, this is the part that's confusing. I want to get rid of that, and maybe all this. I'm going to redo my colors. Here's my colors. This orange is this orange. This red is this red. This green is this green. Are you seeing that part? You have to rotate your brain a little bit. What that does for us is it makes me, instead of saying like I need to parallel this and minus that and do different angles, well now we're just looking at X and Y, which is something really easy for me. Like that's all I want to see is just the X and Y. And if you go back to the question, it's saying parallel to the plane. That means this way. They're saying the X component. This guy right here, that's X. X equals 2.7. If I reimagine it like this. Okay. So, did you want it? Please, comments. I don't know yet. Probably because it's X's cosine. Yeah. I I haven't done any math yet. Other than subtraction. We did subtraction once. But I want to make sure the picture is okay, right? Yeah. Okay. I know it's weird. Sometimes we have to do that. Did we have to do anything like that in Cal 2? I can't remember. With use substitute? No, they don't do that. Oh, yeah. In this class, we're going to have this thing called Jacobians, where we have to do something similar to this. It's way out there, way further down the road. So just we're fine right now. Okay, so this is our imaginary cool picture. And I want to say that x, this distance here, is 2.7. Okay, so x is equal to r cosine theta. And I have, so 2.7 is equal to r cosine theta. What would be my theta? Yeah, 17. I can handle that. Sweet. And then if I solve for r, it would tell me how much force, like total that I need. How do I solve for r? I'll take that. Again, degree mode, so we should be fine here. 2.7 divided by cosine of 17. And so what I have is 2.823. That's going to be my answer. Now, of course, I want to double check this thing, but let's. I'm gonna flash it right quick. I'm gonna flash it. Here we go. 2.82. Yep, we got it. Cool. So, are there other ways to do this? Yes. Do I know those other ways? No. I mean, there's probably a formula, but I don't know if it would be so nice and specific. Is there another example of it in the book? There might be. But what I do is I try to reorient what I'm looking at. We're going to have to do it again later, so it's cool to kind of start building that skill. Good to go? Okay, cool. This guy. So I actually like this one. This is fun. We're wanting to find the equation to line, but I want to zoom in. Can I zoom in? Not really anymore. Notice there's an A and there's a B, and there's an A and there's a B, and it makes me wonder if they're like literally the same thing. Probably. So I'm going to give you a small zoom out on lines. We had this a long time ago, right? That's a line. So what was the M right there? Slope. And so slope is the thing that's tied in with the X, yeah? But we already have that. So here you're going to say, oh, well, my slope is now an A, right? Kind of. We also have a slope for the Y's. And that would be a B. So in a way, I'm saying that my A's and my B's are kind of like slopes. It's not perfect, but kind of getting there. In a way, you see this as a 1, yes? And don't we always say rise over run kind of thing? So if this was like, just say, let's say that was a 5. And so I would say rise 5, yeah? And I would run 1, yes? 1, 5, 1. So they're kind of like slopes in a way, right? They work together. So that's what I'm going to use these guys for. I think that we're going to literally copy them down in there. So here we go. I have ax plus by is equal to c. And so therefore I have 2x plus 3y is equal to c. I'm just literally copying them in there. Okay? So far, so good. Those are like slopes in a way. This point is also x's and y's, aren't they? Isn't that an x and that's a y? Well, hold up, I got those. I can plug those in. 2 times 3, 3 times 2. And what's funny here is that the one thing I didn't know, we can actually get now, right? I plugged in everything we have, and what's my c equal to? 12, yeah. So I have a c equals 12. What I want to do is go back. When it says equation, it means like with letters and stuff, you know? And I think what they're wanting to do is like go back to one of these guys, and we're going to put the 12 in. I would rather use numbers, though, wouldn't you? Yeah, so 2x, 3y is equal to 12. That's my answer. Now, they might change it a little when we go and check out their answer there, but I like that. So let's see what they got. And, yep, there it is. Cool. Awesome. Yeah, like the answer? Yeah. Oh, you want this? You're right. They just keep it the way it is. That format, they keep the same. Cool. We're not used to seeing 2x plus 3y equals 12 as a line, right? Kind of weird. But in Calculus 3, we're going to definitely see that style and more lines and then planes. They're like an extension of dimensions. Ooh, that sounds so cool. Extension of dimensions. So yeah, that's neat. We'll be seeing more as we go. It says choose which one. So just between you and me, I have no clue what the graph looks like. I mean, look at this. Go ahead and graph it for me. Go on. Like we don't do that, right? And now if we had a technique later, that's fine. But right now, let's just go get it to the y equals mx plus b. Go ahead. I mean, remember how we had a 5 and a 1, and I went up 5 over 1. Oh, you're. Oh yeah, perpendicular. Yes. Okay. Well, we're gonna see. We're gonna see. I'm gonna move this. I'm gonna just do the most basic thing per this the round. Move it over the x. Divide by the 3. And so I've got negative 2/3 x plus 4. So so this is the same thing. But now I can graph it. I know what's going on. I need to start at 4. So this guy here, what's this right here? Is that 4? No. 6? I think that's 6. Is this 4 right here? That looks like 4. That's not 4. That looks like a 6 again, and that's 4. So far, this guy's no good. This guy's no good. I got to start with a 4. And then I'm going down 2 over 3. And it looks like both of these do that. If you go down 2 over 3, oh, look. There's an arrow here, and then this guy here, it like goes past it. Let me see what their answer is. They say it's D. So what are they? Oh, it's the original vector. That's what they want. Thank you. The original vector. So yeah, if you look at that, then I went 2 x's and 3 y's. And so yeah, that would be 2 comma 3 essentially right there. I'm going to change my color. But yeah, that's the original vector right there. Okay, well, then there you go. Yeah, this guy. They said just draw. Oh, they said the vector also. I thought I could get him. I thought I could say, you my math lab are wrong. But yeah, it was just me not reading. Okay. Cool? Okay. So we're going to develop more skills with this stuff later. Right now, I'm just trying to do the most basic stuff, you know. How about y'all do all the word problems and I just... How much work does it take? Work. There's a formula for that, right? Force times distance. To slide this crate this much with this much and that much. I do want y'all to do this one, but I'm going to just real quick, force times distance is the formula. First off, draw a picture. I want you to draw a picture. And at least kind of see, how can I apply that work formula? Force times distance. Yes, force times distance. And so in this particular case, that would be our newtons times our meters. It's like that would be the final answer, is newtons times meters. And again, I have the board up. I can, here, I'm going to turn the light on even. No takers. All right. I'm okay with whatever style you want. I mean, don't be scared off by a recording, you know. They can 2 times speed. They can mute. Please do. I would love it. Yeah, draw something up there, and I would love to see it. And we can, like, talk about it and stuff. Oh, and yeah, they'll probably want that joules thing there. You're right, because it's a box there. I'm gonna write this down, and we're gonna talk about it. I want to talk about it like from the beginning. Thank you. Very great. Awesome analysis. Let me do that right there. Okay, so 4,008 something. Yeah, in joules. Perfect. Look at that. So let's. Do y'all want me to leave the light on to copy the board? Can y'all see the projection, or should I turn the light off for projection again? Because I'm going to draw more. Okay, so let's go back up to the formulas, right? Thank you, by the way. Great job. Very good. Let's go back to the formulas. So it just has this one, and that's it. Now, there might have been one that I missed, but I don't think so. I mean, I don't try to miss them, well, except for that one. So this is all we got to work with, right? So, like you said, Mason, we're trying to see what distance it's actually like moving, I guess you could say. And so, was it on a ramp? No. I'm sorry. Hold on. It's not a ramp. It's the angle that I'm moving it at, right? So 26, 26, 26, and it's wanting to go this way, right? That's the work that'll be applied. So I'm only looking at the x component here. And of course, we know that x is equal to r cosine theta, right, from earlier. If I take that as my distance, and then I just say force, which is going to be something or other, then we should be good to go. At least that's what I'm thinking. I think there's something missing, something small missing. Okay, hold on. It's reversed in a way. It's not reversed. It's just like I'm missing a component here, right? The distance that it's traveling is 30, and that's a fixed amount. But I'm looking for the x force, not the x distance necessarily, if that makes sense. So I want this x, which is still the r cosine theta, right? Like there's a y component, but I don't really care about that. So yeah, that's what I'm looking for. Distance is 30, straight up. X is going to be, this is going to be my force. Am I right there now? Okay, I think so. So then we're going to do 180 times the cosine of the 26. That's going to be my force. And I'm doing this by hand, like slowly, if that makes sense. Okay. So then I have 161.78 newtons. So that's going to be my force. This is my distance. So I just multiply them, right? And let's see what happens. Times the 30, and there we go. Cool. 5.3. Bam. All right. So what did I learn from this? What did I learn? What did Chad learn from this? Chad learned that when it says distance, you just plug it in. Right? The 30 meters is a distance. Bam, 30, done. But the force, we still have to find the x component. Yes. Just the x component there. Have you taken physics? Oh, well then that's why you know all this. Good. Cool. Okay, any questions? At any time, I'm fine with questions. Okay, because that's why we have lecture class, right? This looks fun. So let's just find the angle. Already, before I even do anything, I'm thinking this is going to be the arc cosine formula. U dot V, and then we got U, magnitude of U, magnitude of V. That's what I'm thinking that we're going to use, but let's just check it out. So we got a vector, and is perpendicular to this line and parallel to that line. Oh, I see what's going on between these two. We'll talk about that conceptually here in a second. So it is also true that an acute angle between intersecting lines do not cross, blah, 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 blah. Okay, so we have these two guys here. What's the angle between these guys? I think the square roots are throwing me off a little bit. And so what I'm going to do is try to make it look a little bit more pretty. Notice with my square root, I have like this little tail, kind of like stopping it. it just, for my sake, it looks a little better. Okay. I would like to do this graphically for a second. I just want to see something. It's okay to use Desmos graphing occasionally because I want to look at stuff. What does this visually look like to me? So here we go. Square root of 3x plus y equals 7, and square root of 3x minus y equals 8. So these are the two lines. I want to find the angle between them. I'm going to ask, is that 90 degrees? Not 90. So, I mean, it looked like they were talking about this whole parallel perpendicular thing, and I'm thinking, oh, 90 degrees, blah, blah, blah. But it's not the same anymore. So maybe that was just a lot of blah, blah up there. I don't know. So let's find this angle between them. What I need to do is, to find an angle, I need two vectors. And I think maybe that's what this is. It's trying to say, we have a line, you can go back and find a vector for that, basically. I'm a little bit freaked out about that, honestly. I don't know if I would just follow that directly, but it is an idea. Nah, I don't like that idea. I'm seeing how I could best approach this thing. Let's find 2 points and make a vector. I'm gonna go very basic. I'm sorry, you probably already got the answer. You don't? So if we remember, a vector is terminal minus initial, right? And that's basically like two separate points. If I get 2 points on a line, I'm good. I found my vector, right? So what I want to do is find 2 points that are working on each one of these lines, okay? So what can I do to find a point on this line besides Desmos? Just find a random point. It doesn't matter where, just some kind of random point. Let's do that. That seems really good. That's where we know where they're touching each other, which is good. I mean, look, we got a legitimate point regardless. That's like square root something or other. But like there is a point where they're touching each other. I don't think they care about that right now. That's a good point though. Yes. Let's solve for y, because I mean they're kind of like ones. So if I move the stuff over, move the y around, and so then I now have y equals 7. No, I want to do it the cool way. Negative square root of 3x and then plus the 7. And if I change my sign here, I should have a positive square root of 3x and then minus 8. Am I correct about that? I skipped a step in there. Are y'all like, whenever I move it over, it's a negative, but then I switch all the signs? Okay, so I got my two lines in a way. I want to find some points on them though. Like literally, like point A, point B for each one of these. One of them should be pretty easy, especially in this format. There it is. Put 0 for x. Exactly right. Boom, 0x, we get a 7. Bam. Very good. And similarly for the other one, 0, negative 8. Bam. Yes, very good. And we can confirm. Let's just confirm that we're doing this right. If you go back to Desmos, we got 7 and we got negative 8. Look at that. So there's some random points there for you. Thank you. That was excellent. So the second one, it's arbitrary. I have to stress that it's a random, whatever you want to do. What is another easy number to plug in for x? 1. Yes, exactly. Now we're going to get some funky answers, but that's okay. Let's go through this. So if I plug in a 1, I'll get 7 minus the square root of 3. Whoa, that's my y value. Hold up, Jeff. Plug in a 1, plug in a 1. So 7 minus square root of 3. And then the other one will be negative 8 plus the square root of 3. Am I correct about that? I think so. So these are my points, and now I want a vector. I want a vector from each one of these. So vector for each one. We already know the formula. Oh, no. Stop it. Terminal minus initial. Terminal minus initial. Orbital minus initial. And I'm doing this like super crude, but I mean, it will work. So I'm going to go B minus A essentially. Yeah. So what would be my X component of this vector? B minus A. 1. Yeah, 1. And then the next one will be these guys. So I'm going 7 minus square root 3 minus 7. Exactly. The 7s will cancel. We got a negative square root of 3. Very good. So similarly with the other one, you could probably guess the answer now. Positive square root of 3. Right? Okay, so here we go. I'm going to write them out now up here. I know my notes are always a little bit, but we're going to get through it here together. There we go. So those are my 2 vectors that I just computed. They want an angle. I have a formula. Boom. So let's put it in, get the answer. So arc cosine of the dot product. So when I multiply these, I get a 1. When I multiply those, I get a 3. And it's going to be a negative because one of them was negative, right? In the bottom, magnitude. So I have the square root of basically 1 plus 3 twice. And what is the square root of 1 plus 3? Yep. Yeah. So I got negative 2 over 2 times 2. Isn't that right? Need to get rid of all this. I need more room. So cosine of negative half. Let's check it out. Yeah, I think, yeah, it's like 30 degrees or something, Oops, 60 degrees. Oh, 120 degrees. But now they did say acute angle between them, didn't they? Did they say acute somewhere? Right there. So I'm guessing what's going to happen. I want to put 120 degrees, but they're probably going to say something like 60. But, right? That's my guess. Let's see what they say. Of course, that's why we have it up here. There it is, pi over 3. Okay. That was a lot for pi over 3, bro. I've done a different method, I'm sure of it. But I wasn't thinking that way. I was thinking, we need to get these vectors. So make our lines look pretty. Get some points from them to make our vectors. Once I have vectors, I can go formula, done. Any questions on that? That was a tough one. I mean, tough just because it's like multiple steps, I guess. Okay. Yeah. Sure. I could have probably looked at this AB business and B negative A business, and I probably could have just looked at it like this is a 1, and that's a 1. So I probably could have said this was my A and this is my B, and then I could just say this was my B and this is my A and make it negative. You know what I mean? Like there's lots of ways to make this better. But I wanted to go like just as, this is the path that I need to take. I don't want to always think like, oh, there's a shortcut, because sometimes there's not. There was one here, but okay. Good? Okay, cool. Okay. Cross product. We got plenty of time, so we're moving on. Cross product is super important. You already have physics? Did you use cross product? All the time. Have y'all had statics? You have had it? Do you use cross product? All the time. So yeah, let's talk about cross product. It's a very cool thing. This formula here does it totally disservice. That is not good enough, right? There's a lot more behind that. This is fine, but I'm still gonna with this, okay? The cross product conceptually is telling you where a normal vector is for a plane. And this picture is super awesome. I really like it. It's called right hand rule, and that's why you have a right hand up there. Right hand rule. And so I can't show the folks online, but I can show you, okay? Sorry. So imagine that this plane right here, right, is my plane. I want to know the normal vector for it. Well, bam, like coming out of the page, right? A normal vector is both telling me what the plane looks like, so it's a descriptor for what the plane is, but it's also like light bouncing off of it and stuff. You know, if I had to throw this, it would bounce off and hit James in the face, you know, that kind of thing. So like it's this like this angle coming perpendicular from the plane. Cool. So what if I had two different vectors? So I have a u vector and a v vector, right? The right hand rule says I start with my fingers at u and I curl them to v. So I curl in the direction of v, and then my thumb's pointing to the positive cross product. Similarly, though, what if I had a u and a v? A little different now. See, I start with my fingers here, yeah, and I have to curl. Okay, hold up. Direction of v going into the page now. Into it. So that would be like the negative, essentially. Okay. We're going to see all that as we keep going, of course. That's what they're trying to describe here with the right hand. In and out of the page, that kind of thing. So I want to see if there's other formulas for it because there's a lot going on with this. It's really fun stuff. Oh, there's your negative. See, so if you can't curl your hand all the way around, just like switch it, and you'll just point the other way. That's the idea there. Yes, this is really good. I don't think that just trying to memorize them things are good. There's a system to this, and so let me show you. It's like a wheel almost. So I got I, J, and K components, and when you have a cross, you have I cross J, so I cross J would equal the K. It's always like the other guy on there. Did you have physics here with Rabani? Did he do this? Yes. Yeah. Yes. Yes. Yes, definitely. And this is right hand rule as well. It's just more mathy, I guess you could say. So let's say that I had J cross K, right? So J cross K would be my I. It would be the other guy in a way, as long as you're going counterclockwise. Cool. What happens if I have like K cross K? You're not going anywhere, right? You're doing this, and basically you end up with a zero. That's why there's these little guys down here. Okay. If you're going the opposite direction, J cross I, so we're going to opposite, right? Let me do a new color for that. J cross I, see, we're going like against the flow. That's not the way we should be going, and therefore negative K, negative, because they're opposite of the flow. That right there, it's handy, it's helpful. You practice it, you learn it. It's like unit circle, right? You just kind of figure it out, but up to you if you like it. Cool for the introduction. Cross product is super useful about, again, these describing the planes. It'll give you this vector right here, which basically tells you what the plane looks like. If I said vector 2, 3, 4, it tells me exactly what the plane would look like. I'm not going to draw this very well, but it's going to show that I have a plane and it looks something kind of like that. This vector right here is the 2, 3, 4, but the plane is very described by that vector. You can just like see it if you know what that vector is. Okay, so let's keep going. This is a cool formula. They're going to pop this one up. I remember this on the homework a lot, where they're going to say find the area of a trapezoid or whatever. So just have that around. It's the magnitude of the cross product. Okay, we'll just see that as we go. Ah, What does it mean when a matrix has straight vertical lines? I know. Determinant. Determinant. Have y'all done that ever before? We've cut it out of college algebra for a couple years now, and so I'm not expecting y'all to know determinants. But it used to be a very handy way of getting these guys when we used to use matrices a lot more. Not required. I don't use it personally. I do use this, which is insane, but it actually is so beautiful. We're gonna learn how to do cross products in this messy looking thing, and you're gonna yeah. Oh, you did. Oh, good. Good. It's clean. It's a clean way of doing it. This is the algebraic way, and it's messy. But to me, I remember how to do this. Like I could probably do this without looking at the formula. It takes me a minute, but I can still get it. You'll see there's patterns. We'll get to that later. Let's just kind of do one or two and kind of figure it out together. Okay. So we're just kind of saying, hey, what is this cross product? U cross V, and then we can keep going from there. So I want to do it. I want like more. I want more paper. Give me a. Y'all can write tiny. I need more paper. So here we go, because this is going to be super fun. I'm going to write down the question, and then I'm going to draw all over this and have a great time with you guys. So 4, -2, -5, and then I have my v is 5, 5, 0. Very good. -5. Excellent. Thank you. So, and it says just find the cross product. So we're finding u cross v, and this is going to be super awesome. What I do is I actually leave it just like this, and I do a little cross and I underline it. And I'm going to start filling in each piece. I'm foiling it. I'm foiling it. Now, have you ever foiled a 3-term to a 3-term? It takes a little bit of time, but you've done it and you know how to do it. I'm going to foil this, okay? I know that sounds weird, but here we go. So, lots of different colors. Trying to make it clean. 4 times 5, 20. But now the problem here is that what we did was I cross I, 0. So in the end, this will actually end up being a 0. The number is 20, but because this guy is going to be a 0, the whole thing will be a 0. I don't want to do that yet, but like that's what we're anticipating here in a minute. Next one. Let's do 4 times 0. Is 0. Very good. So, and that's going to be I cross K, or J. I cross J. Sorry. The answer is going to be a K. I cross J. And again, that's going to be K. We'll do that in a second. And then finally, 4 times -5. -20. And that's I cross K. Notice that I'm trying to keep it clean by doing like those 3, listed out. And then those next 3 listed out. And it actually does start to be a little bit more clean than other methods. I'm going to use a different color. So now I'm going to do the -2 with the 5. Makes -10. But again, remember that was a J, so I got J cross I. You don't need the hats. If you're going fast, you just don't need the hats, but I'm particular today. Go ahead. Yes, please. Yeah. Cool. I love it. I, J's, and K's. Yes. And you can put them down here if you like. Yeah, exactly right. Yes. I agree. Whatever you want, whatever you need. The next one, -2 times 0. And I know it's 0 and you don't really have to write anything else, but I'm trying to show that pattern on the very first one. And then I got -2 times a -5 is a +10. J cross K. Awesome. We already did green. We already did blue. Maroon. Okay, here we go. Last one. -5 times 5, -25. And that's a k cross I. Like I'm purposely. No, that's not it. I'm purposely not doing the letter math yet because I don't want to like confuse myself. I just want numbers right now. So give me numbers. Just set numbers. -5 times 0, 0. Again, that's a k cross j. And then finally, -5, -5 makes a +25, k cross k. Now, most of this is all just going to go to 0. There's like a whole ton. You're just going to cancel, cancel, cancel. It's going to be great. Cool. Yes. Stage 1, So stage 2, I want to do the letters. I want to do these letters. So I got, let me go back to the colors. So I got 20 times, and then I cross I is a 0. And so like this whole thing's going to go away, but I want to, show my notes about what I was doing. 0 times anything, but I still want to do the letters. I cross J is a K, yes. And then we got a funky one over here. So I got -20, and then I cross K. So let me just real quick redo my little circle thingy. I'm doing I cross K is definitely a J, but because I went against the flow, that's like not with the flow that's clockwise. It should not be that way. It's going to be a -J. Okay. I have other techniques that I'm going to show you here in a second to make it even faster with the letters. So keep going, -10. J cross I, -K, right? J cross I. Again, I'm going against that flow. That should not be clockwise. Anytime 0 is 0, but what's J cross J? 0 again, so 0 plus or 0 times 0. And then I got the 10. J cross K is going to be a, yep, plain old I. You got it. And then finally, we have -25, K cross I. K cross I, we're actually going the correct direction finally. It's just a plain old J. We got 0 again, so it doesn't matter. But what's K cross J? I think it's a -I, right? And then finally, we got 25 times 0. So I'm going to just slash through everything that's a 0, so I don't have to keep calculating it. So that's a 0. That's a 0. That's a 0. That's a 0. This is a 0. We don't need those, but I wanted to show that flow. Like, hey, what am I actually doing behind the scenes? If I just showed you the simplified form, it might, I might lose it whenever it's not a 0 there. So what do I have left? And this is where I actually start using the alligator stuff because I want my I components, my J components, and my K components. So I'm going to look at all my I's. What I's do I have? Just the 10. Just the 10. There's no other I's. Just the 10. What about J's? Positive 20. And then -25, which will make a 5. Very good. Yep. And then finally the K's. Yep, just a 10. You got it. So final answer, I'm going to have to write it down tiny here. 10, -5, 10. There's my cross product. Whew. There are quicker ways for sure, but it's best to get the small ways down first. Then you can kind of do the shortcuts. And I'm going to show you a shortcut, at least one that helps me so much because that takes forever. Let's go and check. So that's going to be my answer. So let me put that up over here. So we had 10, -5, 10. And I want to just check. Am I doing it right? And oh, the length. They didn't want that. They want the length of it. Okay, so magnitude of that thing. Ugh. See, they're always going to try to get me. So I have a 100 plus a 25 plus a 100. So I have the square root of 225. Is that 15? That was 15, right? Yeah, 15. There it is. All right, cool. Oi. Now, I want to show you some shortcuts, if that's okay. We got time for we don't have time for shortcuts. Do you want me to show you? I'll show you a tiny shortcut. You're not running off the class yet. Let me do one more blank, and this will be very quick. We know that the results of our cross product will be a 0 right here, a k component, and then a negative j component. Here we'll always get a negative k, a 0, and an I. And then here we get a positive j, a negative I, and a 0. And this style for the letters is always like that. As long as you're doing the my foiling thing I do, you'll always get that. So you don't have to compute 3 of them. You know where to look for these. Some of the things I remember is that like these guys are opposite of one another. You see that? See that? They're like opposites. And so that's how I remember where they go. Because I already know the K, and so this guy right here has got to be the negative K. And then negative J has got to be the opposites, positive K. Or positive J. Blah, 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 blah. So that's a quicker version to get the letters. And the numbers, you know, we crank out numbers real fast. So pop them together, boom, and you got a really quick method. Cool? Okay. We'll do a lot more next time. Like, that's where we stop. So we'll finish that up next time. Thank you, guys. Y'all have a wonderful rest of your day. Thanks for hanging out. Yay. I got to stop the recording.